Next item we're going to talk about is methods and functions. Let's say with a method, it's essentially like taking a chunk of code, like if we took the code here inside the for loop, moved it somewhere else, and gave it a name so that we could call it, then every time we wanted to repeat it, we just have to call it by that name. It's another way to reduce the amount of code you have to write. If you need to do a certain operation you need to do to your data, you might have to do it in different places in your program. By putting it in a method that you can call from those different locations, you save yourself from having to duplicate the code. It helps prevent errors, and it makes coding a lot faster because you can generalize and solve problems and reuse that code in other places. So typically you're going to hear two different types. There's methods, which is something that's going to evaluate and return a value in a procedure. With a procedure, you call it, it's going to do its thing. You're not concerned about any sort of return value. So typically they're both methods, but a procedure really is just kind of a method with a void return type, because you're going to call it, it'll do its thing, and you're not worried about it, versus a method where you're actually looking for something coming back from it. Let's see the declare one. You've actually already, if I scroll back up here, you've been working inside of a method. This here static void main is declaring a method inside of the class program. We're going to go ahead and add some additional classes inside the program, or some additional methods inside the program. So come down here, this curly brace ends the body for main. Okay, first thing we're going to do is declare a procedure. We will make it static. We'll talk about static a little bit later. It's a procedure, so void call it display greeting. We'll have it take a string and for this, for methods, the basic format is going to be any static is an access modifier. We'll talk about that later. But the basic format, what's called the method signature, is your return type. Void in this case. The method name, which in this case we've called it display greeting. And any method parameters. Let's see, in this case, we just have a string called message. This allows us to pass a string into the method when we call it, which makes that data available to the method. So from here, we're going to console write line, and the only thing we're going to have this do is display the message. Now if we come up here, to call it, we just type display greeting. Anywhere in the program we could do this, and we need to put something in there. The stereotypical message would be hello world. If we go ahead and move this down just to get rid of the code from earlier. So the only thing we're going to show now is our display greeting. Go ahead and run that. And it shows hello world. So what happens is the code hits this line for display greeting. It's going to call into our method, or in this case procedure. It gets the argument hello world passed into this message variable. And the console write line we're using with the value that was passed in and displaying it to the screen. Now if we want to write a method instead of a procedure, we will go ahead and make one that's a little more useful. So when you're doing input, something I've kind of glossed over throughout the program so far, or throughout the lesson so far, is that there are some crashes in the program if the user isn't nice and enters incorrect values. We'll create a method now to help with that. So we're going to create one to validate an integer input. And for this, we'll put static on here. Makes it a little easier to use right now. Later we'll talk about static and why you should limit how much you use it. And for this, we're going to return an integer value here. We're going to create a variable for that value that we're going to return. I'll call it validated int. And we take input from the user. I know I'm going to use it right away. I'm going to initialize the string to null anyways for safety. It's a good habit to get into. And realistically, we should initialize this as well. You will see the red squiggly line. It says there's an error. It's because we're supposed to return an int. We're not returning anything yet. We will fix that. Now, to do the validation properly, we need to use a loop. And inside the loop, we're going to ask them to enter a value. We use write instead of write line. We need to catch that value, which is where the input variable comes in. And it's a do while loop, so we need the while. In our condition, what we'll do is, instead of using the convert to int32, problem with convert to int is it will crash every time if the user does not enter something that can be converted. But if we look at int, let's see, if we look at int32, it has a method on here called tryParse, which means it's going to try to convert the input to a value. It returns true or false if it works. It returns true if it works, false if it fails, instead of crashing. Now the second argument that this method takes is called an out, and as a result, this is how it gives the value to you if it succeeds. In this case, you have to acknowledge that you know it's being used to return a value, so you put the word out there. And we're going to put the validated int. Now if tryParse fails, it does set the validated int to 0. So that's something to be aware of. You do need to do this in a loop and make sure you are checking the return value. If you just accept the fact that you call tryParse once, it's going to have a 0 in here if it fails. That may not lead to your expected result if you're just assuming that you have a good value because you call tryParse. And it does return false if it fails. So if it equals false, we want to keep looping. If it's true, it succeeded, it will not equal false, and we will exit the loop. And the last piece we need to do here to make the compiler happy is we need to return the value, which we said we're going to return an int. In this case, validated int is what we're going to return. So this is an easy way to, in a single line, get a value that we need and ensure that it is safe for us to use. Ensure that we will get the value we want. To use it, just do something like this. We'll do int and I could do this on multiple lines. I'll just do it on a single line. We call get int. We use string interpolation. And we'll display the number that the user entered. So we can go ahead and run this now. You can see the enter an integer message. Means that the code came down here, displayed greeting. After executing this method, it returns to the same line, goes on to the next line. Here we're creating the variable, have the assignment operator. It sees the method, so it knows it has to call that before it has a value to assign. Called into our method. Went into the loop, because it's a do loop. It's guaranteed to go at least once. And enter an integer. We can see that's the message we see right now. Now if we have a user that's trying to crash our program, they can't do it. Finally, they have to give up, enter a number like we asked. You see the program from there. Came back out here where our display is. User entered the value. User entered the value. And there you go. There's a nice, helpful validation method to help prevent your program from crashing. Say loops and methods help you write more complex code quicker. They allow you to take large blocks of code like this and simplify them down to smaller chunks of code that are reusable. You could even put this input in a method like the validated int, have it in there, and then inside the loop you would just have one line calling that method. Say they help you divide the code into smaller logical units and help as you're writing the program. You can get complete one piece, test that piece, make sure it works. By doing that, it helps write larger complex programs without having to build the entire program and then run it and try to fix a million errors. Say as much as you can, you should try to think of programming more like building with Legos. Go a piece at a time, make sure that piece is good, and then move on to the next.